So I'm Dennis, and I'm going to talk about decentralizing data distribution. So yeah, we founded a company called Greta, which is doing just what I'm going to talk about, decentralizing data distribution. If you have any questions after the talk or during the talk, please ask them. And as well, I'm available at just dennis@greta.io. You can also find that on the homepage. If you have any crazy ideas or thoughts about what happens about this stuff. So Greta is my father's grandmother. So it's taken sort of because we didn't want one of those super technical names. So we took a Swedish name, basically. So we're also recruiting our first employee. So if you think this is really interesting after the talk, come and talk to me or Victor, and we can plan something or have coffee or whatever. So just a bit about what Greta is. It's a startup. We took in some money this summer. We developed a distribution script, which turns every visitor into actual points of presence in your distribution network. And we're doing this over WebRTC, which is really cool because then you can go for it in the browser natively. So the topics today, I'm going to start shortly by talking about let's continue. So shortly about what WebRTC is, just because I'm interested. How many know what it is by heart? By heart. Yeah. And how many have built something? And how many have used the Datachannel? Yeah, cool. So just very fast, what it is, how it works in the basics. Then what you need to think about when you sort of decide to decentralize data distribution. Some in between there, we're going to talk about different options we have sort of faced and we've seen in different deployments. Some security in this sort of systems. And why do you do this? And then hopefully I'm going to do a demo where we stream some video between two peers and you can see it actually working. So WebRTC, it's a standard. So it's built into browsers. It's mostly used for video chat and audio conference systems, stuff like that. Google Hangout. It's getting to be quite supported, I would say. Chrome, Firefox, Opera, Edge is doing ORTC, but that seems to turn out fairly well because it will integrate with WebRTC in a good way. And then we have native for all the platforms, including phones and iOS, Android, and stuff like that. Apple's plans are, as normal, played very close to them. But there are a fairly cool product, I think, WebRTC in WebKit, which is Ericsson trying to merge their implementation of WebRTC into the WebKit core. So if you build stuff on top of WebKit, you could actually use WebRTC in that, which is cool because it's used in a lot of built-in systems. So
standard, is it an RFC or?
It's V3C, I would say.
Okay.
So it's in there. I don't know exactly right now what state it is because I think they're sort of closing up on 1.0 and are finalizing that. So it's gonna be hopefully very well supported. But I mean, if you do Chrome, Firefox, Opera, and Edge, I mean, then down the line you're gonna get very high numbers of users that could use this. There are basically three parts. There is the RTC connector connection, which basically gives you the ability to make the connection between peers. You can then create a data channel on that, which can be reliable, it can be ordered, or any combination. And then there is another part, which is get user media, which gets the webcam as a stream and the mic as a stream, or either way. And then you can also pipe that over the RTC peer connection. But today we are going to talk about the data channel because that's what I would say you have to use, at least for now, inside systems like the Greta system and when you decentralize data distribution on top of WebRTC. So what will happen is that data will be served between peers in your network, and it will use the WebRTC data channel. This is possible today for audio, video, and images. Audio and video is using the media source extension, so you actually could pipe every piece onto a video buffer or audio buffer and play that back. Images can just be displayed when you have the full thing. And of course, you can send like arbitrary binary data over the peer connection, which means you could build any sort of data distribution if you yourself know how to handle the binary data you get. It's very effective when you want to like lower load on your servers, because you will distribute stuff further out in the network, which also gives you really interesting possibilities because you get really low latency connections with fairly high throughput. So you can actually append, like the load time of stuff will go down, which means you could usually go higher in quality in video, and you can go higher in quality in audio, and you can also distribute images faster and build applications that's very like latency fragile because you have these low latency connections. And I think, for me, I think the most interesting part is basically the fact that the more users you have, the more distributors you have, and thereby the system scales in a very organic way, which is really cool when it comes to running this in production. Were there a question or? Nope. So I'm going to go through the flow of distributing a piece of data and what happens. And we're going to make a few stops. There are yellow bubbles. And they tell us, then we're going to sort of talk about different choices you can make for different parts that you're actually going to need. So for the first part, since it's in a normal website, it's just added to the normal response from the homepage. So in this case, Sophia requests a homepage, and she gets it. And in this response, there is references or the JavaScript to the logic of the actual network, how it's going to behave, how do you connect, what do you do with the data. It's served like normal JavaScript. Then you somehow need to get information about the network. You can bootstrap it or something like that. You need information about the network to get that. So in this case, in Greta's case, you would go to a meta data server, basically, which returns a response with some channels you should be listening on based on your location, some ISP information, and some stuff like that to be able to organize a network around you later on. In this case, you could use a tracker, which BitTorrent does, which actually contains all the hashes. Do anyone know like the BitTorrent tracker and torrent formats? Yeah. So it's basically hashes for every piece, and it's also peers to connect to bootstrap the network, because you somehow need to find out where other peers are. So in this case, we have a metadata server because we've done other decisions further down, but BitTorrent has a tracker then that returns a lot of the information you need to find the pieces and to bootstrap your network. So this part is fairly WebRTC specific, because when you have WebRTC, you actually need to exchange an offer and an answer, because that's how it's decided that you need to do it. And it's not specified how you do that. So you can make a lot of decisions, but the system needs to manage two requirements. You need to be able to send an offer from one peer to another peer, and that peer needs to be able to send back an answer, and then they can start communicating with the peer-to-peer connection. But you need a system to do that. So we have built a system based on Erlang because we didn't find anything that scaled as hard as as big as we needed it, and it wasn't fast enough. But there are plenty of choices. We use WebSockets. You could use external services like PubNub or Pusher or a bunch of them. We found them to be too slow to give a good user experience, because the time you spend in your signaling system is so tightly connected to how long it takes for you to connect to another peer. So you want that time to be really, really minimum, because that's sort of the overhead you have to pay to create a connection. There are server-sent events. There are examples where people actually do this manually, because you want to be able to like have a completely serverless WebRTC project, which means you somehow can manually move these actual text blocks from one computer to another, and then you would be able to create a peer-to-peer connection without like having a signaling system. But that doesn't really work if you are building something for production. So now we add Emma to the mix. And Emma have already done all the steps that Sophia has also done. So now we're sort of getting to the interesting part. You have to choose good peers. If you spend time connecting to everyone, you're going to exhaust the client machine because it won't really do it. And you will also spend a lot of time connecting to people that you can't get content from or won't give content to, which means you have to somehow figure out which peers should be gone so you don't spend time on them. In what we have found this far is that what we really want is closeness in like the network architecture. But that's really hard to figure out beforehand. But geographical like positions, so if you're close to each other geographically, that's fairly good, because you will probably be quite close to each other also in the network. But the absolute best would be to actually know these peers are close to each other in an actual network, but that's really hard. You can do things with like having two peers in the same network, which is a really, really good fit for sending data, because then you turn around in the Wi-Fi network. So geographic location, also ISP makes some impact, but not as much as I thought when I started Greta. I think if you do really, really, really large networks with a lot of data, you might get more benefits for the ISP doing that, because they don't need to peer with other ISPs, which give you better results then. But we haven't run a network yet where we see that that's like a really, really key factor. Also, that you have content, of course, that these users actually want to look at the same content, or one of them have it and the other one needs it. It's also something that you sort of need to sort out. And then you have the offer and answer process. You also probably want to do ICE tickling. ICE is a protocol used to actually figure out how the peers should connect to each other. And if you can bootstrap that process sort of by every time your client has a new ICE update, you could send that over the signaling system to the other peer, and you get lower connection times, which is, as I said before, the overhead you sort of pay. So it's everything that can bring down the connection time is really, really good for the system. And after all that, you have a peer-to-peer connection. So now Sophia and Emma can talk to each other. Now they somehow, either through the tracker that made them connect to each other, know that who has what of this file that we're going to share, or this content. We don't do that, because then every time someone sort of has a new piece, we have to send that to a centralized system. We have to know who has what, and that won't really scale in a super lean way. And since we are building a decentralized system, you want to push everything you can to a decentralized level. So we use a distributed hash table. So for every time two peers connect to each other, they tell each other what they know about other peers having content. So they basically sync their DHT. And the DHT is sort of interesting, because in theory, any peer could know everything of the network, but only if they actually had been connected to everyone or know someone that had been. So that's sort of interesting. That's never happened. That two peer, that someone actually had the full thing. But they always have enough to do what they need to do. They always have enough to figure out the peers I'm connected to, who has that content, and can I use them to get it. And I think one really important difference here, when you build a system on top of like the existing internet and existing web infrastructure, you don't need to go for the rarest piece first, which BitTorrent have done for a long time, because you can always fall back to the origin, which means you can go for the best user experience, which you have seen a lot of BitTorrent systems do over time. They have tried to like reorder that, say, always get me the stuff I want to look at, because that's how streaming works, and people don't want to wait for the download to finish all the way yet. So that's a benefit of doing it on top of something, and that's always there and reliable. So they figure out how to get content from each other. I think there are a lot of things you could do here with, like, in development, and bring it forward in doing it in a smart way that peers could actually, like, you could introduce peers to other peers through peers, so then you don't need a signaling system when you have bootstrapped it. But then you also want to be able to make decisions. So if Emma knows things about Sofia and another peer called Per, you could make Emma be the center and signaling system and make them connect, and thereby have a truly decentralized system when it's bootstrapped. But then Emma needs to be able to make the decisions if Per is a good fit for Sofia. And I think you can do a lot of stuff to figure out how to make those decisions in a distributed manner. But when you know who has what content, in Greta, Sofia will then ask her DHT and say, okay, I need content, I need this content. And we identify content based on the hash of the actual URL, or like host plus path, because the naming system of the internet is one of the really great things. So we hash that, and we ask the DHT, this content, who has it? And then it will respond with either I don't know. And if it's I don't know, then you have the absolute awesome benefit of just fallbacking to a CDN or the hosting solution that people have today. If you find a peer or a list of peers, you have to make a decision on how or from whom should I get it. And there are, as I see it, two things you have to make decisions about. Which peers are the best ones? And should I get everything from one peer, or should I get it in parallel from multiple peers? And you have to figure that out somehow. Basically, I would say it's the normal things when you look at a connection. Have I asked Emma for a lot of other contents? Emma have a lot backlist on distributing content to me. Maybe then I should pick someone else. Do I and Emma actually have a really good connection? Have I had timeouts on my connection to Emma when I was waiting for content? So there are, like, that's, I would say, fairly normal, just like network stats you can go on to figure out that sort of things. And you also have, like, when do you know if it's a good fit to get all of the data from one peer, or should you be dividing it and say, you can give me 10 pieces, you 10 pieces, and you 10 pieces, and get it from 3 different peers. There are some overhead on requesting content, because you have to actually send out a request, say, hi, I want this content, I want these pieces. But that's fairly low. But you also have maybe one of the peers actually are serving a lot of other peers, so they won't serve you. And then they will come back to you and say, oh, I can't do that. So you need to find someone else or get it somewhere else. And for some content, as we see this far, is that it's really effective to just split it up amongst a lot of peers, especially if you can get, so if you stream video in HLL or Dash, you have like actual predefined pieces. And it's really good to go get like pieces from different peers, but always the full piece, because then it's really, really easy to fall back to a server solution and bring down just that piece, and you still will be able to get the rest of the pieces from the network. But there is also a lot of like logic that you have to figure out and do in a distributed manner, because you don't really have a full picture of it. So you send out a request to the peer you have selected to get it from, and it will then respond with the piece. When you use WebRTC or also other protocols, you need to chunk the content into smaller pieces and be able to buffer that in a good way and handling it in both ends of the connection. So you can consume the data when you receive it, and the sender can't just overthrow the buffer on the connection and stuff like that. But that's sort of normal. So that's all the steps that you take to distribute content. And a lot of places, I would say, where you can find better algorithms, you can decide on better solutions and stuff like that. So is there like any part of this that anyone like sort of jumps at and have a question, or yeah?
So the hash is based on the content in another case, or
yeah?
So you have the authenticity is like given by the hash, so you know that.
And that's sort of that. We have the next slide is security.
Okay.
But yeah.
Because so if you use another, if you don't use the hash as a key,
yeah,
then you have to have some other mean of
knowing it. Yeah.
Yeah.
Absolutely.
Authentic content.
Yeah. So we're getting to the security part, but yeah, you need some way to figure out both like address the content in the network, but also the authenticated. And I mean, merging that together can be good. That also means that either someone needs to tell you about the content beforehand or tell you the hash of the content beforehand. That's why we don't use the hash of the actual content, like the verification hash, as the key in the DHT, because then you need to ask someone for the key firsthand. That's why we use the actual UL with like the path and everything for the file. But yeah, you need to verify the content. Otherwise, someone can change it, and that's not good at all.
What's the typical time to establish?
Right now, we're seeing in like the worst case in our systems of peers we actually then decide to get content from around a quarter of a second. But we spend, a lot of time on pushing that down.
You said the PubSub is slow.
Sorry?
PubNub is slow.
Yeah, we couldn't really use them because they didn't manage to get us to those connection times.
How do you gather statistics like that?
You measure the time from you know about the peer till you actually open a connection. And I mean, if you measure it the same with both systems, yes. Yeah. And we had a question.
Yeah, I've got a little bit more general question.
Yeah.
That's a stupid question. I'm just wondering, when you talk about content or data in this context, you necessarily mean a data or a content which in nature is not like a real-time protocol, like a file or something. Is that correct?
No, I mean, we do live streaming. Live streaming video is fine in a network like this. It's really awesome because all the peers want the same content at the same time.
Yeah, but streaming is bufferable, still not a real-time protocol, like in video conferencing or like a...
Yeah. No, in this system, I mean, if you want to use this for like a video conference system, you should absolutely go for using the video stream and the audio stream inside WebRTC and not using the data channel because they have that support. When I talk about data or content in the sense of this network, we don't care inside the network. We only treat everything as content and like binary data most likely, because then you only need to know when you need to piece the content together, if it's an audio or if it's video or images. You don't need to care about that when you distribute it. But the question about real time in the sense of like a live streaming football game turns out to be really good. You can usually distribute to very many more peers, and also you can usually get higher quality because peers can find better ways of getting the content than actually always falling to the server. But for a video call, use the video channel and audio channel. So, any more questions? Yeah?
The idea here is basically that I can get the content from one of maybe 10 peers, but what's keeping me from writing a plugin that my web browser or something that instead of asking 1 out of 10, ask all 10 to get response time as low as possible to me.
Yeah, but I mean, that's what I mean when I said you can get different pieces of the content from different peers.
Yeah, but what if I just ask all peers for it? Just to make it quicker for me, I'll overload the whole system if everyone's doing it, but what's keeping me from doing it to make sure that I get the best?
Nothing really in a generic system, but you can build in like in Greta we have detection mechanisms, and I think that's it's here. We use a gossip protocol in the system, so every time we can identify malicious behavior, like downloading the same content 10 times for the same thing, we will actually blacklist you. And we will tell everyone in the network too, this one, no.
It's basically not possible to use blacklisting for, definitely this one is not trustworthy. It's IP address. We're talking about internet. How can you blacklist something and change it?
Yeah, you can change the IP address and do it again. Yeah, of course you can change the IP and do it again. But I mean, then you're sort of doing a normal DDoS attack against the system, and you could do that to any system today. You could have DDoS detection, but
like my basic connection at home, I've got these 4 IP addresses. So it wouldn't be that hard to at least make it look like 4
different peers. That could work. And I think we would detect you fairly quickly before you could do any bigger harm to the network. Sorry?
Challenge accepted.
Challenge. Yeah, please. Always.
Quite large IPv6 network at home.
Yeah.
Sure. But I was thinking, how do I exclude myself from this? Disappear if I'm, for example, have a limited bandwidth or have a bandwidth cap.
Of course. So there are means of turning WebRTC off in the browser. Under Chrome internals, that thing, or flags, I think it's called. But that's the specification, that for data channels, this is a peer-to-peer stack, which means you don't have to have the allow for camera and microphone, so to get user media. That's behind the flags in Chrome, and you need to say, I allow this to happen, but not for the data channels.
Okay.
There is a change coming, which means that it will always decide on using the default interface. So if you use like a VPN or anything else to sort of anonymize yourself, then it will actually go through your VPN, which it doesn't do right now. But that's inside WebRTC in like the Chrome. Those guys are like upstairs. So
for example, let's say that I'm just an old grumpy person and I don't like Greta. I can't set a cookie or actually have a setting somewhere that I'm not using your stack, for example.
Yeah, for our specific stack, there is one.
Okay.
But that's provided by us.
Yes.
Yeah. But there is like no generic one. So I think both like turning it off and also never using like a method connection, that's up to the implementation. Which I think is both good and bad, because if you do it responsibly, then that's going to turn out fine. If you try to abuse it, it's a system, you can abuse it. There is also just some other notes, like I don't think it's a good idea to, like, if you build this in a generic way, have personal identifiable information except the IP, which you need because it's a peer-to-peer system. It's also very good to have some sort of flow control in the signaling system. So you can't, I mean, you could basically say that you want to connect to a peer so many times that that person's computer wouldn't really work in a good way. So you need flow control, and you need ways of excluding peers quickly if you see anything strange happening. And you could also, I would say, have peers excluded in your signaling system, but then again, how do you identify them over and over again? Yeah.
Question. The browsers limit how much WebRTC bandwidth can give to a page. Isn't there some limitation?
I'm not completely sure if there is like a percentage, or if it's just like normal connections, that the available space divided by the number of connections that needs them. Like, I'm not completely sure. We haven't seen any like throughput problems yet. When you actually have connections that we want to use to get like the speed. I would say that both Chrome and Firefox have improved immensely when it comes to the speed in the actual data channels. Anything else? No. So I think we covered most of this during questions. So you do this because you want to be able to distribute data, of course. It behaves like a normal CDN with POPs, but the POPs isn't data centers that someone built and like actually have, because it's dynamic. It's your peers. Yeah. POP is a point of presence in a CDN network, which is basically a place of origin for the content. So it's a server hall with machines that has your content cached on them. Was that clear? Yeah. So you will get points of presence spread out over the wall, but instead of that being data centers that I have like gone out and purchased and set up my tech stack in, that would be your users. So every user will be also part of serving content if they sort of meet the requirements of having WebRTC and can actually upload content and stuff like that. So this is really interesting in very many cases where CDNs isn't that built out as we are used to in like the US and the Western of Europe. If you take South America, we have seen some people having like this trying to distribute content in like Argentina, and they can buy CDN services, but then they get one POP and they already have your hosting in sort of the same place. So that doesn't really make sense for them. And like they can actually build a really like big CDN network throughout using a decentralized distribution network and not having to build that all over the country. It will just sort of grow up when they start the service. You will also, of course, then move load from your servers or CDNs. So less bandwidth and load on your servers. You will get interesting cases where you get these very low latency, high throughput connections where you can get really fast load times and bring that down. And you can also get like the higher quality, which is really interesting, especially if you have markets where the internet is worse. So then you can go from, then you might not be talking about going from like HD to full HD. You might be talking from going to like from basically like the lowest quality to a good quality, which is actually an enjoyable experience to watch. And then, yeah, the interesting part where it will scale really, really interesting when you add people. Yeah.
When you said the thing about South America,
yeah,
its own network, how long is this persisted in the browser?
Just as long as you are on the site. And then there is, I mean, that's also up to how you implement it. But we have a cache of content that's actually manageable in a slightly different way than the actual browser cache. So you don't reload if it's the same images and stuff like that, because you already have them. And you can that's also interesting when it comes to the fact that you can talk to them and you can actually make them like turn their cache invalid.
Right, so I thought if someone like has the tab open to support some cause, or you know, like, or if you can support, if you can persist it in the local storage.
Yeah, so we like the data is persisted, but not like you can't serve it when you have left the page. Yeah, and there is a discussion right now going on with service workers, if anyone are familiar with them, and actually letting peer connections in there. Yeah.
What if I have a tab open somewhere in the background?
Yeah.
I need to check this later, and then 3 months later, I still have the tab open.
Yeah.
Do I still keep serving out?
I mean, that's also up to how the implementation is made. I mean, in theory, yeah, you could be serving for 3 months if that's how you build it. Of course, every responsible delivery of a system like this shouldn't let you serve like 10 times as much or even 10,000 times as much as you have consumed. There should be some sort of ratio. But who knows?
You haven't considered that as part of Greta or something?
Yeah, we only let you serve like a specific ratio compared to what you consume, and we won't let you serve for infinity, because then as like the use case are that you most likely forgot about it and it's not just lying there, and we don't really want to abuse your client. So yeah, that's why you do this. Now I'm gonna try to demo it. It's always a bit, yeah. So on this is gonna be confusing. In this one, we're gonna start the playback of. Let's actually take a look at the code. So this is just a like normal HTML file containing, in this case, the Greta distribution script and the -JS player. So it's a dash stream, which is a protocol for streaming like adaptive bitrate streams. And the -JS is like the reference player. So no real like magic in that, just -JS. And then the Greta script, which will load in the actual network in form of Greta. And there will be no one else in this specific distribution network that I'm setting up right now. There is just like the normal video tag. We have a div that will just contain some long messages. And then I just start the player, say I want -JS. This is an example test stream we have that is dash and stored in like the Google storage. It's autoplay true, it's not live. And then just please print the logs to this div. So let's fire that one up. And it will start to stream. And since I'm the first one here and no one else have been here, we will not connect to anyone else, and we will have 100% server. Because I'm just streaming this as I would do in a normal case. Which is just, yeah, streaming. And then if we load, let's move this a bit. Then if we add another peer, we will start see that one start streaming, and it will hopefully start to get some peer-to-peer data. So we can have a look at the logs later. Now, you can just see that 97.6%, 7% is distributed from this tab to this tab, which means that it has not requested the content from the server in any sense in that case. And you can see it plays just as fine. Yeah.
Or sent 14 megabytes.
Yeah.
The first tab.
Yeah, this one.
Yeah.
That's the size of the video, basically. So this pair have now distributed this much data to this one. And that's why we're seeing this sort of number for peer-to-peer.
So it started at 0. It started at 0 and went up to 14 really quickly.
Yeah, because we have, I mean, I'm in this computer in the Google Wi-Fi, which means I'm distributing it from there to there by just being inside here. Which means
2.2%.
they come from the server.
Right.
I would say we can have a look at it. I would say that it's probably like the 2 or 3 first chunks, audio video chunk. I would say, and also if everything worked in the demo, there should be pieces in the beginning that didn't verify, which means that this pair didn't send the correct thing over here, and then we didn't use them. So then we went out to get them. But let's see if that's in the logs. So if we start with, yeah, of course.
Imagine that you have all the persons in the world with the tab open, and you have only one server here in Sweden.
Yeah.
How long will, if you change the content on the page on the tab, how much time will it take to a person in Australia see the difference coming? Because the content will change.
But I changed the content on the origin server, right?
Yes.
Yeah. Then, I mean, you could use like our APIs to tell people that you want them to refresh their content by using, we have a signing system where you can send signed messages out in the network. But I mean, basically it will work like it does today. When people re-request content, they will get it from your server if you have invalidated the cache. Otherwise, if the cache is still valid, they will use the cached content. But there is no means of like saying in this system, I mean, you could build a system like that where you were a local client and you could push like data out in the network. and we only allow people to get data at this point. But pushing content is a use case you could totally build. Yeah.
If you replay one of those, how much will you get from the cache?
Nothing in this case, because I didn't want to be able to have to fiddle with setting the caches back and stuff like that if I needed to refresh it. But yeah, you could cache it in the index DB is used if that's available in the browser, which means you would actually save a lot of users if they watch the similar images or same content again. You will save them a lot in the cache, but you have cache today as well. Yeah.
So when you look at for chunks of the video,
yeah,
what is the strategy that you follow? In general, the rarest first strategy is good.
Yeah, but I mean, I want to start the playback as fast as possible, and that's the goal. The goal isn't to get as much peer-to-peer data as possible. In this case, I would say, you could build a case like that, and then it's really good to go for raddest piece like BitTorrent, because if one piece is missing in BitTorrent, all the rest of the pieces can't really be used. You will miss one piece. But here, if you miss the piece, you go to the server. It has the piece. It will be there and give you the piece. Which means you can go for give me highest speed instead of pieces. But that's also that's completely on the implementation level and how you sort of build your algorithms about how you should think about the data in the network. Yeah.
I have 2 questions.
Yeah.
First one is about policy.
Yeah.
So if it hasn't happened yet, I guess that at some point someone will implement something like popcorn time with the platform. What would you do in this case? Would you just shut it down? And the second question is regarding popcorn time. This other project, which is the underlying infrastructure that does the distribution. How much of this code base and the code base from WebTorrent do you use for your systems? Or so it's just came out with the standards?
Yeah, we have built everything ourselves, and we as a company is from this summer, but we've been spending time since 2012 when if you could make it work in Canary if you really, really, really wanted to. So we've been developing a system and built other services on top of it, like the normal ones, video chat, and just normal file sending and stuff like that. So all our technology is Greta's, but of course there are systems. And I would say if someone wants to build a system like Popcorn Time on WebRTC, they're probably going to use one of the open source platforms at this point. Is my feeling about it. I mean, they if you take WebTorrents, for instance, they actually work with BitTorrent files. It's sort of a hint. So yeah, that's how we do it. So we don't use any of the other projects. We built this stuff ourselves. Yeah.
I want to ask about if you see benefits using in the mobile phones, because the latency is higher than connecting to peers should take more time.
Yeah. At this point, we only download on Android phones. We never let them seed. Because we can't in a good way determine inside web browsers if we think the battery levels are really good. Then there's a lot of other features you have to consider when you're using mobile phones. But they get the benefit of downloading. And they
even over 3G and 4G networks.
Yeah, we've seen some cases like that, where the 3G connection and 4G connections still get the speed, but especially, of course, when you are on a Wi-Fi network. Yeah. No more questions? So, yeah.
Well, a follow-up question when it comes to popcorn time.
Yeah.
I had a question about if you have a server that serves some kind of copyrighted content, and then someone rights organization attacks one of the peers because, oh, you were sending this copyrighted file.
Yeah.
Do you have some kind of way of protecting the peers? That's
No. We don't have that. We don't plan to build a piracy distribution network. We think this has a valid case for valid services.
So you're relying on monitoring your customers and pick out if they were.
No, I mean, if you look at a lot of the CDNs as well, like Cloudflare, which has an open sign-up.
Because if you're just distributing the distribution of content, you also like opening up for a lot of like lawyers to attack all the peers because you sent this private file.
But I mean,
and they weren't even aware of that they were sending something.
People using Popcorn Time are aware, I'm quite sure.
Yeah, but if you're visiting a site,
of course.
I don't know.
No, but I would say
I view the source on every site I visit. I can't say if you're using your service.
Yeah, but you will never also be serving content from a site that you haven't been on.
Okay.
That's
so my crime is
one
that
of
I
the.
visited this site.
I'm not the judge of your crime.
I'm not only consuming, I'm also distributing.
Yeah, but if you look at services,
or I should turn off WebRTC altogether.
No.
And then I can't talk to my wife anymore because we're using Hangouts all the time.
Yeah, but I mean, I would also say that if someone builds a system like that, and you look how the rulers or data distributors have handled it today, is that if you look at Cloudflare, for example, they have an open sign-up. They were actually used by Popcorn Time for serving their stuff, and like they are not the ones to blame in that they are a service. People can use that. Of course, we would not want people to use it for.
Like, then you have Cloudflare, but in this case, you have like this ISP customer.
Yeah.
Like,
but I would say then you're just in the same case that you are in Popcorn Time or other services that you use.
But I'm confused. You only stream to a peer if the original guy is visiting the page.
No. You stream to appear if you are on the page.
Yeah, exactly.
Yeah.
Exactly. So it's only if you are watching the copyrighted content that it would stream to someone else.
Yeah,
so we will never like prefetch or
legally. It's totally different if I'm only consuming or if I'm also sending. Yeah. Oh, okay.
Yeah. But then most systems like that today are built around you sending.
Yeah, but I don't use BitTorrent.
No, but
I'm using a web browser.
Yeah, of course. Yeah.
Also, what's keeping me from setting up a page that contains a simple game like Sudoku or something?
Yeah.
And then when people are using that game, they are in fact distributing movies and so on. They just don't see that material.
Yeah.
But it's going on in background.
Yeah.
What's keeping me from doing something like that? And then they come to
yeah, I would sort of say like, why would you do it? What's your benefit?
Because I can get other people to have quick access to these movies.
On another site?
Yeah.
Yeah.
Or actually on the same site, but just a private part of it.
Yeah.
So basically I could get people to pay to get to the sort of secret site with all the movies. And then I have innocent people that think they're just playing Sudoku or something that are distributing.
Yeah, but you still need them to get to the page. And I just see the case that's sort of far-fetched. Yeah.
It doesn't look like that if you have a copyright organization because all they see is the material going in and out. From
yeah. If you focus on the piracy side of it.
Yeah.
Yeah.
It's not just the focus on secure piracy part. The main, I think the essence of what we're talking about is that are there enough security measurement on what you're doing? Because you're going to the semantic search basically. And semantic hashing, you are going to get what's the content? And I'm using that as hash function. Then I get some hash fingers and distribute it between everyone based on some algorithm. But this itself can be problematic if we go with the security part because it's not that easy to just hashing based on what is in content.
No.
You cannot do it, especially when you go with that, you're saying that based on the study that you have been doing, the geographically closer peers have the better performance on giving data and servers and everything. Yeah. So when you go like this, you basically have no guarantees on having the same content on the same geographical distribution. So your hash would be on different plots. Different chunks.
You mean between countries?
Yep.
Yeah.
And then it would be quite harder to guarantee any kind of security. Because if it gets out of just having something like, for example, a stream of movies or audio, then you go to picture or then go to text, then it somehow becomes just complex for solving.
Yeah.
Yeah. That's the part. And then how you can guarantee security on that? That the content could be easily manipulated.
Yeah.
You have only 24 consideration for the outputs that you get it. And that's the point. Actually, how you can guarantee that part for security and giving some kind of guarantees that, okay, this content which I hashed here are going to be the one that you actually want to
see.
And they do not manipulate it.
Yeah, and you mean manipulate it in a way that you get the same hash. Yeah. But I mean, I would say that there is something called sub-resource security, which is something worked on by Mozilla, where they have seen problems where CDN injects things into your JavaScript. And they are working on a system also using hashes to sort of verify that the CDN isn't messing with the system. And that's something we are looking at as well. You could be able to integrate that into Greta as well and use sort of, I would say every time you can stand on something actually in the browser is a very good thing. Because then there have been a lot of scrutiny of the protocols and thinking about it. And for like the talk about like how do the data channel behave in the browser, when should I need to turn it off and stuff like that. That's not something we're really involved in. That's the working group and the guys in there, which means that's where you should focus in those sort of discussions. There were from a different talk earlier, there was a presentation where Serge and Justin like sort of cemented that to get camera and microphone, HTTPS and allow, and that's not what we're gonna do for data channels. So if we just look quickly on, are you at all interested about what's like how the system behaved in this case? Let's have a look. So here, will this be a, will you be, tell me when you see it. You see it? Yeah. So it's a very short movie, but what would happen in the beginning here, and where we have only one peer, is basically that it would just try to find the hash in the network and find a good peer. It would not see it, and it would start requesting it from the stream, like a normally used -es implementation. And then further down here, we'll see that we introduce the new peer. We have some ICE completion and checks. We open a channel, and we start to stream data. And we managed to send the data quite fast, I would say, to the other peer. And for every piece here sent, the other peer have sent a request to them to get that. And then we have this one, which is the one receiving. And here we can see some just assumptions about how fast we can process the pieces we get. Here we have the same. We will start seeing it. Connection, we'll see that we do the sync. We'll see that we fail in one hash validation. And then we fall back to get the content from the server instead. And then the rest of the pieces clear the system. Here we had a few more pieces that did fail. And we continue to get peer-to-peer data. And that's how it was played back. That was all I had. Do we have more questions or stuff like that? Yeah?
To continue on the security stuff.
Yeah.
Do you feel that data channels will also be put behind the flag?
No, I don't think so.
Camera and microphone.
No, I don't think so.
Because there was this precedent by New York Times newspaper that they were gathering your local IP addresses.
Yeah, and what was coming out of that was that you decided to use the default network interface, which means if you are using something to hide your IP address, it will decide on that interface and not go for a different interface where you can make the peer-to-peer connection. And there was an extension released by Google for that you can install in Chrome, and it will become the default behavior. So that was sort of where that discussion ended this time.
Okay, but still that doesn't protect a lot.
No, but
know that this happens and they need
no, but that's, as I said, that's part of the browser implementation. We provide a way for you to set like, I don't want to be in this, but how the data channel is implemented in browsers is we just built on top of the technology.
Maybe there should be some visibility on whether
you are part of it.
Is using data channels.
Yeah, it could be like the blinking red thing in recording. Yeah, I would say that that's something you could bring up with working group. Anything else?
So why did this hashes fail?
I built actually in, so it removed pieces to simulate that.
Corruption.
Yeah, we didn't get all the pieces.
Okay.
Yeah, and that's since this network I was guessing would be really reliable. I still wanted to.
Bouncing on the inside the computer on the network.
Yeah, I mean it's gonna be really. This is like the best case. So that's how or why. Just so you could see that. Yeah, it actually works even if you have like package losses and stuff like that. Yeah.
Have you considered using like the BitTorrent strategy to reward peers that also send you a lot of data?
Report peers?
No, reward.
Reward.
Peers. So if a peer is sending you more data, you would prefer them if you have several peers requesting it at the same time.
I would prefer them over other peers.
Yeah, exactly.
And maybe we don't do right now. I would say basically in many cases now what happens is that you get a fairly, it's not static, but when you ask again to get new content, it's very often happening to be the same. So you sort of get a semi-direct way of the data flowing, which might be good or not, depending on the case.
Alternative to the blacklisting of ill-behaved clients that instead you prefer clients that are well-behaved and also reciprocal.
Yeah, that might be a way. Yeah. Yeah.
What would be the technology?
When a lot of people want this, say live streaming is of course a good example, but also when you have other sort of events where like the image serving and stuff like that is also interesting. Twitch, yeah. They're streaming a lot of video live, so and backlist. I mean, the more peers you have, the more like stable and sustainable your network's gonna be. So having many people wanting the content or having the content is good. Yeah.
The more peers I have, the bigger site and everything, the more Greta becomes the unknown factor that could go down or something. I mean, I could serve maybe 100%, 100,000% of what my servers can handle.
100,000%. Yeah.
And my server starts.
Yeah. What would happen then in our system is that we will fall back, and that I would say.
It would fall back to my server.
Yeah.
That means that for my whole business model,
if
I'm relying on you a lot, then you're the big unknown. And if your service dies, then my whole.
Yeah, I would say that if you're that big today, you basically have your own CDN or you pay for it from someone else, which means you would fall back to them, and they are your unknown today, and they would probably be able to take the load.
Have you any plans on offering the service of actually having your own servers, talking Greta and everything? So
we have considered it, like an on-premise, yeah. We've talked about that for bigger customers.
What would happen if you go down in the middle of the World Cup final?
Yeah, if they have enough like CDN capacity, they would fall back to the CDN or their hosting.
The P2P connections would still stay up.
Yeah, if they are available, but you would never create any new ones. Yeah, so you would sort of, when people drop off, you would also be dropping off the like how effective the network are, and then you would fall back to the system, which I think. For me, it's a really big part of why this is where you could do this as a small startup, because you can still say to people that use it, keep like your CDN today. You're gonna give them a smaller chunk of money, but they still will be there when you can't use the peer-to-peer technology. Yeah.
So basically, your target audience businesses are the ones that want to save money, not the ones that want to grow beyond what they're able of.
No, I would say that both of them are very interesting, and also I would say that the quality aspect of it, where you can actually give your users a better experience, is really good. When they can actually stream your content in a higher quality or at least watch it is really the biggest benefit for the companies. Yeah.
So how does your pricing model work?
We don't have one at this point.
So you're thinking about it. So
yeah, we want people to try it out because we want to test as many cases as possible. Because every time we test a new case, we sort of see new stuff, learn new things, and are able to run it. And that's why we are backed by money. So we can do that to people and let them try it and see what happens. Yeah? Are we done?
One more.
One more.
I still have a little bit of an eerie feeling about how you authenticate data.
Yeah.
So you say that in your DHT keys to look up data is the actual hash of your URI, right?
Yeah.
So when you ask your peer that you connect to, hey, send me this.
Yeah.
When you get that content back, you recalculate a hash on top of that to actually calculate a hash of the content to see if it's correct.
It's actually for every piece of content.
Yeah, but who's authoritative on that hash? Because the hash for the actual URI is in the DHT. Who sends the hash that matches the content?
Yeah, that could be done either by the actual server, by using the sub resource integrity, or it's done in another way inside the network.
Right, but right now, who does that?
Right now, that's done by either the server, or they could, if they would like to, have a solution where they fall back to us, or it's done inside the network.
So for every content block that your browser is getting, it would actually have to ask the server for the actual hash.
No, not for every content. And basically, no one is really using the fallback system where they get every piece.
But I'm a little bit confused how you actually authenticate the content.
Yeah, we do that by sort of peers that get it from the server have a higher ranking, and then they have to compare to other peers in the network.
But if NSA has a lot of peers.
Sorry?
NSA, if they have a lot of peers,
yeah,
then they are the authoritative part.
But I mean, they already have a network. I mean, we don't build a new network, or are still in the same network.
So I'm free to inject the rogue content as long as I'm better than anyone else.
Sorry?
I'm free to inject rogue content as long as I'm better than the rest.
Better than anyone else. No, it's more complex than that in how we decide on the hashes.
So that's a secret sauce for some security.
Part of it. Yeah. Part of it. Yeah.
That doesn't quite seem sensible to me, actually. If you are, I mean, I'm just trying to piece together how you are literally right now authenticating the content.
Yeah.
I don't see how you're doing it.
No, and I'm honestly gonna say that I'm not gonna answer the question straight out exactly how it's done, because it's
security by obfuscation.
No, it's inside the system, and I'm very happy to talk about it off camera and see your part of it, but I'm not going to tell you exactly how it works out here. Thank you.